have this one life to appreciate the grand design of the universe.
Many existential questions remain unanswered despite everything we've learned about our universe. We don't know if our universe is finite or infinite in extent. We only know that its physical size must be greater than the portion we can observe. We don't know whether our universe encompasses all that exists or whether it's only one of many universes making up a multiverse. However, we are certain that the universe has an edge, not in space, but in time. The hot Big Bang occurred at a known finite time in the past, 13.8 billion years ago, with an uncertainty of less than 1%. There's also an edge to how far away we can see. Even at the speed of light, the ultimate cosmic speed limit, there's a fundamental limit to how far back we can see. The farther away we look, the farther back in time we can see. So here's what we know as we approach the edge of the universe. But first, if you haven't subscribed, do so. And don't forget the post notification bell. Without further ado, let's get rolling. Today we see the universe as it exists 13.8 billion years after the hot Big Bang. Most of the galaxies we see are clumped together in galactic groups, like the Local Group, and rich clusters like the Virgo Cluster, separated by enormous regions of mostly space known as cosmic voids. The galaxies within these groups are a mix of spirals and ellipticals, where a typical Milky Way-like galaxy forms an average of about one new sun-like star per year. In addition, the normal matter in the universe is mostly made of hydrogen and helium. Still, about 1 to 2% of the normal matter is made of heavier elements from the periodic table, enabling the formation of rocky planets like Earth and complex, even organic chemistry. While there's a lot of variety, some galaxies are actively forming stars. Some have active black holes, some haven't formed any new stars for billions of years, etc. The galaxies we see are large, evolved, and clumped together on average. But as we look farther and farther away, we start to see how the universe grew up to become this way. As we look to see greater distances, we find that the universe is slightly more uniform, particularly on larger scales. We see that galaxies are lower in mass and less evolved. There are more spirals and fewer elliptical galaxies. On average, there are greater proportions of bluer stars, and the star formation rate was higher in the past. There's less space between galaxies, but the overall masses of groups and clusters are smaller at earlier times. As we go to greater and greater distances, closer to the edge defined by the start of the hot Big Bang, we start to see even more significant changes. When we have to look back at distances of 19 billion light years, that corresponds to a time when the universe was just 3 billion years old. Star formation was at its peak, and the universe was maybe 0.3 to 0.5% heavy elements. But as we close in on 27 billion light years away, the universe was only 1 billion years old. Star formation was much smaller, as new stars formed at rates approximately a quarter of what they'll be later on at their peak. The percentage of the normal matter made of heavy elements plummets precipitously to 0.1% at the age of 1 billion years to just 0.01% at around 500 million years. Rocky planets in these early environments may well have been possible. And when it comes to the cosmic microwave background, it was significantly hotter. It would have been at an infrared rather than a microwave wavelength, but every galaxy in the universe should be young and full of young stars. There are likely no elliptical galaxies this early on. Going farther back than this pushes the limits of our current instrumentation, but telescopes like Keck, Spitzer, and Hubble have already begun to take us there. Once we go back to distances of approximately 29 billion light years or farther, corresponding to times when the universe was 700 to 800 million years old, we start to run into the first edge of the universe, the edge of transparency. Today we take for granted that space is transparent to visible light, but that's only true because it isn't full of light-blocking material like dust or neutral gas. But at early times, before enough stars had formed, the universe was full of neutral gas and hadn't become fully ionized by the ultraviolet radiation from these stars. As a result, a lot of the light we see is obscured by these natural atoms, and it's only once enough stars have formed that the universe becomes fully reionized. This is, in part, why infrared telescopes such as NASA's upcoming James Webb are so crucial to investigating the early universe. There's an edge to where we can see the wavelengths that we're familiar with. At distances of 31 billion light years, corresponding to a time of just 550 million years after the Big Bang, we reach the edge of what we call reionization, where most of the universe is mostly transparent to optical light. Reionization is a gradual process and takes place unevenly. It's like a jagged, porous wall in many ways. Some areas saw this reionization happen earlier, which is how Hubble spotted its most distant galaxy to date. Still, other regions remain partially neutral until nearly a billion years have passed. Going back even further, there are additional edges of interest. 44 billion light years away, the radiation from the Big Bang was so hot that it became visible. If a human eye existed, it would be able to see that radiation begin to glow red, similar to a red-hot surface. This corresponds to a time just 3 million years after the Big Bang. As it appears to us, the edge of the universe is unique to our perspective. The universe has many edges: the edge of stars and galaxies, the edge of transparency, the edge of neutral atoms, and the edge of our cosmic horizon from the Big Bang itself. For the past 11 billion years, the universe's evolution has been slowing down. Sure, gravitation continues to collapse structures, but dark energy begins to work against it, dominating the universe's expansion more than 6 billion years ago. New stars continue to form, but the peak of star formation is in our distant past. And supermassive black holes continue to grow, but shone at their brightest earlier on, with a greater fraction of them fainter and inactive today than during these early stages. Still, beyond the limits of our current instrumentation, stars and galaxies must certainly have existed. The most distant galaxies we've ever found show evidence that previous generations of stars have lived within them, and they're already quite bright and massive. Beyond the limits of what our current telescopes can see, however, we can still measure the indirect signs that stars have formed. Through the emission of light from hydrogen atoms themselves, which only occurs when stars form, ionization occurs, and then the free electrons recombine with the ionized nuclei, emitting light in the aftermath of that. We are taught that young galaxies existed as early as 180 to 260 million years after the Big Bang. These proto-galaxies formed enough stars to see the first hints of their existence buried in the data, corresponding to a distance between 34 and 36 billion light years away. Although our current telescopes cannot see these galaxies directly, the great expectation of many astronomers is that James Webb will. There is something else very strange and unexpected that astronomers discovered in 2008. They found that galactic clusters were all streaming in the same direction, of over 3,000 kilometers per hour. It is a phenomenon called dark flow. This movement of galaxies defies all predictions about mass distribution throughout the universe after the Big Bang. This means the edge of the universe is not uniform. Speaking of mysterious structures, one very large structure is called Hercules, Corona Borealis Great Wall. It is so big that it makes up 11% of the observable universe. Astronomers have no idea of how this Great Wall formed. This means that there could be giant structures out there pulling on everything, including space. In terms of the law and physics of existence, there is still a myriad of things that we are clueless about, which may be completely impossible to comprehend right now. But no matter how long it takes, I wouldn't rule out the possibility of reaching the edge and maybe beyond. If we figure out a new law, it could open many possibilities. For example, how did the Big Bang come to be? How is it physically possible for existence to emerge from nothingness? Are there other universes, if not Earth, out there in the abyss of space? All these questions that are lacking answers currently, but some of them might be answered with tech advancements. But for you, what do you think? Comment below. Also, go through the channel for even more videos of this nature. Thank you so much for watching. Until next time, be safe.